Hey guys, today we're going to be starting the building a phylogenetic tree project. You want to make sure that you read the instructions closely. And what we're going to be doing is building this phylogenetic tree right here. So you're going to use this pattern overall to lay out your pages. You're going to find the back set of pages in this packet is the actual phylogenetic tree that you're going to have to lay out on your desk to be able to go and place your organisms within there. Notice the most ancestral or the oldest organism goes right there at the base. We'll take a look at that oldest organism in just a second. So let's go over the instructions for this lab. I'm reading right off the page right here. Make sure that you follow along. You've been given 58 animals to classify into a phylogenetic tree showing evolutionary relationships. 11 are alive today and hence will be at the end of the branches down here. So they should end in the most complex organisms. The rest are ancestral or fossils representing animals that have gone extinct. The animals near the tips of the branches will have gone extinct more recently than the ones near the bases of the branches. Your tree should look something like the one to the right. If you cannot figure exactly the tree, so there are 11 branches, don't worry. I'm more concerned that your choices make sense, i.e. that you've classified in a way so as to reduce the number of changes or mutations between closely related species to a minimum. We'll go over this in more detail in just a second. So it says cut out all 58 animals and tape or glue them down to the paper into a pattern that shows your tree. As you cut them out, keep the numbers attached. Read the following questions before you try to build your tree. Use the numbers of the animals in answering your questions. All right, take a second before you do anything else and answer questions 1 and 2. You want to make sure that you're looking at your animals correctly. So let's take a quick look at our actual animals. Here's our first page. You can see we've got all these different organisms. All of these are going to need to be cut out. Notice you've got little numbers that go along with each of the organisms. I want to point out to you, number 1 up here, this is the most basic organism on your tree. This should go at the base of your phylogenetic tree. It's only got 2 body parts. It's got a small head. We think that's a head anyways, and then a body. And so number 1 is going to be going at the base of your tree right there. So number 1 goes right here. You're going to be placing it on your tree overall. And by the way, let's take a closer look at how you're actually putting together your tree. What I'm going to do here is I'm going to go to the very back of the packet, flip over. You'll notice the back handful of pages here are pieces of paper that have a section of the phylogenetic tree printed on there. It is the same pattern that you see on the cover of this lab. So you're going to want to rip these pages off, have them as separate, please, from the first 2 organism pages. You're going to build your phylogenetic tree that will match this pattern, and that is what you're replacing your organisms over. So the idea here is to go and complete your phylogenetic tree, starting with the most basic organism, number 1, in some sort of a way so that you can see the gradual change into all of these other more complex organism types, representing the different species as they are branching out and eventually turning into the things that are at the tips of the branches, which are going to be generally the most complex organisms. You want to minimize the number of changes per generation as much as possible. So in other words, you should not be making a jump from like number 1 to say like number 9 or number, well, maybe 4. Do you notice 4 is pretty similar to number 1? Okay, so we could say maybe number 1 to, do you see any other ones that look a lot like number 1 but don't represent too much of a change? Maybe number 15. So maybe our evolutionary change goes from 1 to 15, then perhaps to 4. Do you notice the changes that happen there? Number 1, its head got a little bit larger. That's number 15. Then number 15, it picked up some eyes. That's number 4. It's only 1 change per generation. We would not say that we could go from like 1 to 2. There's a couple really distinct changes that have happened from 1 to 2. This one has 4 legs. It's got a Y-shaped head. It's got eyes. None of those things are on number 1. That's 3 changes right there. That is too far of an evolutionary jump to have these 2 right next to each other. You'll also notice that our species here are giving us clues about their evolution based on all these different traits. These things have a Y-shaped head. These things, for example, do not. Okay, so every single time you see one of these traits, like a Y-shaped head or a pod-shaped head like these things, that probably represents a population that is splitting in two, or one of the branches on your phylogenetic tree. So perhaps, I am not saying it's this way, but perhaps the Y-shaped head organisms would be on this cluster of branches out here, or this cluster of branches up here, or these over here. So your job then is to place these organisms, minimizing the number of changes on the phylogenetic tree. Now, one of the nice things about the iPads here is we don't actually have to bother with taping and gluing these things down. What I want you to do is just to place these things on your phylogenetic tree, and then as you're making progress on this, if you feel like you want to save your work or you want to turn the assignment in by the end of the day on Friday, what you're going to do is just take a picture of your overall phylogenetic tree with the organisms placed correctly on there. You don't have to tape everything down or glue it down. So all you need to do is cut these little guys out. You know where the scissors are, by the way. They're over there in the white cabinet. Grab yourself some scissors. We're going to cut out our organisms. This is going to be due by the end of the period on Friday. Everybody needs to turn this in by the time they're leaving on Friday. So what I'm going to ask each period to do is to cut these parts out. This is individual work, by the way. You are responsible for your own answers, but you're going to be cutting out your organisms. Once you've got your phylogenetic tree papers laid out on your desk and you've got your organisms sort of placed out, start categorizing these things in some sort of way that makes sense and try to figure out where all these things sit on the phylogenetic tree. To keep your work till tomorrow, take a picture of your phylogenetic tree with the organisms on there. Make sure that you've got everything laid out correctly when you take that picture so that you have something good to start off with on Friday. And then let's just leave our parts. You want to stack up all the pages of your phylogenetic tree. Just make a neat little stack with them. Place your organisms right on top. And we're going to place them against the back wall, against these lab tables right back here. So make sure that your name is on your papers. Make sure that you've got everything laid out right there. And this is where we're going to place this. Let's have the different classes please lay out their papers. In the very corner right over here, let's get this to be 5th period, please. In the center portion right here, let's get this 6th period. And then actually, you know what, let's go with 8th period over here in the far corner. That way they don't get mixed up with each other. Okay, so just go ahead and set your papers out there. We will leave them alone until the next day, and we should be in good shape. That is how you complete the phylogenetic tree lab. Remember, what you're turning in from this lab is the photograph of your completed phylogenetic tree with your organisms correctly placed, showing the evolutionary relationships going from one basic organism into a variety of more complex modern-day organisms. Thanks, guys. Bye.